Okay, so we're going into 7.3. Ladies, this is a really short chapter. This is in your book on page 209. If you want to follow along on page 209. So, in 7.3, we're going to be talking about metallic bonds. There's a few things from this section that I am going to omit. Coordination number, we're not going to talk about coordination number. I took it down from the vocab word wall. You don't need to know what coordination number is. All right, so in metals, metallic bonds are formed, and we describe the model of a metal as being a sea of valence electrons, or the valence electrons are like a sea of electrons. They can be modeled like a sea of electrons. And this gives the metals its distinct properties. And so in metallic bonds, there are forces of attraction between these free-floating valence electrons and the positively charged metal ions. And so you have these free-floating valence electrons. It's kind of hard to imagine. So metallic bonds are very different than ionic bonds. And they have very different properties. Ionic compounds have very different properties than metals. That reminds me, I need to go back and talk about the properties of ionic compounds. We didn't get to that yesterday. So let's talk about the differences. I'm going to go back. Let's talk about the differences in the properties. So ionic compounds have three properties that we did not talk about yesterday. Three important properties. And this is on page 204 in your book. One, they are crystalline solids at room temperature. Ionic compounds are crystalline solids at room temperature. Think about sodium chloride, NaCl. Yes, sorry, I don't mean to backtrack, but I just remembered we did not talk about the properties of ionics, and we need to touch on that. So think about table salt, NaCl. That's a crystalline solid. They have very high melting points. If you're ever playing around in your kitchen, see if you can melt salt. They have very high melting points. The reason they have such high melting points is because the forces of attraction between the cations and the anions in ionic solids, they're very strong forces. So it takes a lot of energy to break those apart, to break those ionic bonds apart. And that energy, think about if you have to put a lot of heat into something to break it down from a solid to a liquid, that's because it has such a high melting point. It takes a lot of energy to break those bonds or those forces of attraction. And this is just showing in your book all the different types of ionic solids and the way their crystal structures look, or the way their crystal solids look. And there's a lot of really beautiful crystals from these ionic compounds. And so we're skipping coordination number. That has to do with how the crystal structures are formed in ionic bonds. It's a little complex. We're going to skip over that. The third property you need to know about ionic compounds are that they can conduct an electric current when melted or dissolved in water. When melted or dissolved in water. And so, ionic compounds completely dissociate when they're put into water. Dissociate means they break apart into their separate cations and anions, their separate ions. They break apart. And so you have these free-flowing ions when you dissolve the ionic compounds in water. And as a result, it lets electrons flow easily. And that's how they conduct electricity when dissolved in water or melted. And the flow of electrons, that is electricity. Anytime electrons can flow easily through something, that's when electricity is conducted. We are at the end of 7.2 talking about the properties of ionic compounds. And so this is just showing you a picture of molten salt. Molten means melted. And so sodium chloride melts at about 800 degrees Celsius. And so they are showing a picture down here. They are using it at a solar facility to absorb and hold large quantities of heat, which can then generate electricity. So that's what this picture is on page 206. So those are your three properties of ionic compounds. You need to know those. And that's it for ionic compounds. So let's go back to metals. So we said that metallic bonds are these forces of attraction between these free-floating valence electrons and the positively charged metal ions. And you can think of this as a sea of electrons. And because this sea of electrons, it gives way to the many physical properties of metals. If you remember, you might want to write this down again. Metals are good conductors of heat and electricity. And it's because these electrons are able to flow easily through the sea of electrons. That's why metals are such good conductors of electricity. They are also ductile. Anybody remember what ductile means? Elizabeth? Can be formed into a wire. And they are also malleable. Anybody remember what malleable means? Lucy? Hammered into thin sheets. Think about aluminum foil. And so there's your properties of metals, which we learned before. We have talked about that when we talked about the different types of elements. We talked about metals. And then in 7.3, it goes on to talk about crystalline structure of metals. And I'm going to skip that as well. Get into all types of structures when you are forming metals. Let's talk about alloys. Anybody know what an alloy is? You heard of alloys? Alex Hearn? I wouldn't say compounds. They're mixtures. Anybody know what they're mixtures of? What are we talking about? They're mixtures of metals. Alloys, it can be more than two. They are just a mixture of metals. We may have mentioned that word when we talked about mixtures early on in the school year. But yeah, alloys are mixtures of metals.
Is that like if you go to a ring store?
If you go to what?
Like a ring store.
A ring store, jewelry. Alloys are used in jewelry, yes. The reason alloys are important is because their properties are often superior, meaning better or stronger, than their component elements. What does that mean? What does that mean? Their properties are better or stronger or superior to their component elements, Elizabeth?
Like when they're put together, there's when two or more metals are put together, they're stronger.
Yes, when they're put together and combined, they're stronger than just the ones that are separate. So that's why alloys are important. Now, let's look at some things that alloys are used in. Your book gives lots of nice little pictures, things that we use in everyday life that are made up of alloys. Jewelry. This is a picture of sterling silver bracelet. It's 92.5% silver, but it's got 7.5% copper in it. So it's got some copper in there. And so that probably makes it stronger than just having pure silver. And it doesn't tarnish as easily. And then we have a cast iron skillet. Anybody's parents cook with cast iron skillet? Yep. Okay, we have one too. It was my husband's grandmother's. And so it's mostly iron, 96% iron, but it's got 4% carbon in there. So it's a mixture of iron and carbon. And then the nail clippers here are made from stainless steel. Your flatware, your forks and knives and spoons are probably stainless steel at home. That's a mixture of metals. We have 4 different metals in those: iron, chromium, carbon, and nickel. And so it's these combinations and mixtures of metals that make them so superior. It may make them stronger. Maybe the color's better. They don't tarnish as easily. Better properties when they're mixed together. And that's the end of 7.3. Very short section. This is a very short chapter. So, in my last class, in first period, we had a discussion. I'm at the end of this chapter. We can have a short test on chapter 7 on Tuesday. It could be worth 50 points. The other option was to combine chapter 7 with chapter 8 in a couple of weeks and have one big test worth a lot more. And my first period voted on having a short test on Tuesday over chapter 7. Okay, good. You all are in agreement. So that's what we're going to do. We're going to have tests on Tuesday over chapter 7. It's a very short, there's not a lot of material. What's on Tuesday? Well, we're doing a lab tomorrow. I don't like to have tests on Monday, but that would be another option. If I move the test to Wednesday, I don't know what we're going to do on Monday and Tuesday because I'm done with chapter 7. That's my problem. You want to test on Monday? Well, keep in mind, it's only going to be a 50-point test. It's going to be a short test. There's just not a lot, and I've skipped some of this material in this chapter. So that would give you 3 tests on Tuesday, but this would be a short test. I just don't know how I could move it to Wednesday because we'd have to start a new chapter on Tuesday, and then you have your test on Wednesday, but that has to start new material before you take this test. Okay, let's do it on Tuesday. And I'll post the Kahoot. It's in the form of, have y'all ever heard of the program Quiz Is, IZ? It's like Kahoot, but it's easier to do at home, and so I will put that. That's over, it's the same material we did the Kahoot on, over section 7.1, section 1. So that would be something really helpful to study. All right, couple more things. I need to do a homework check. I'm going to do a homework check. We've had a couple of homework so far in this chapter. And then we're going to do, I've got an ACT practice problem I want us to do. That's at the end of this chapter.